My name's Mark Girolami, and although I'm in the Department of Mathematics as a statistician, I'm actually a chartered engineer and spent over a decade as a professional engineer in industry. But I want to talk about this whole idea of what we would call data-centric engineering and why it is absolutely essential, I would argue, for innovation and infrastructure at this particular time. And I think it really does dovetail into what Jennifer has just been talking about with regards to complexity and resilience of infrastructure. So let me just briefly introduce the main players. The Alan Turing Institute is the UK's National Institute for Data Science, and the Lloyd's Register Foundation is the charity arm of the Lloyd's Register Group, the Marine Group, Energy Group, and so forth. And in 2015, the Lloyd's Register Foundation set up a partnership with the Alan Turing Institute, supporting a program in data-centric engineering to the value of 10 million. And in January this year, I was appointed as the director of this program. The program consists of 3 grand challenges, and those 3 grand challenges are led and run by academics at Imperial. So over a third of the 10 million budget is flowing to Imperial and funding work that we are doing for this. I'm going to give you just some highlights this evening about resilient and robust infrastructure and the grand challenge that we've set ourselves there. But let me just point out that Professor Julie McCann from the Department of Computer Science at Imperial is leading this. And we are looking at the resilience of water supply networks. We're looking at the cyber-physical interaction between physical networks and sensor networks, so sort of science of sensors, if you will. So we're working predominantly with Thames water and so forth. We're also looking at agriculture, precision agriculture, and what I'm going to talk about specifically is infrastructure as civil engineers would understand it. So urban infrastructure, and in particular bridges of all things. The second grand challenge is how do we monitor complex engineering systems, complex engineering infrastructure for high consequence events, which are typically ones which are very rare. So how do we monitor these systems and flag potential black swans, as it were? And then the final one is following on from Jennifer's comments about design and engineering design. How can we exploit data to aid or even revolutionize the engineering design process? And in fact, Jennifer is going to be leading this grand challenge from Imperial. But let me just focus on resilience of infrastructure. So if I just look at classical assets and their management, and in particular, let's focus on bridges, then, well, the management is typically heavily reliant on visual observation, as you can see here. And there are many advances in technology, the use of drone technology and robot technology, in managing assets of this size. But one thing that is probably, in fact, it leads on to, I think, the next speaker as well, is the whole idea of assets or structures that are self-sensing. So in other words, they're capable of determining their own internal state and the development of that state over time, and then being able to communicate that to those that are managing that asset. And in essence, what we are doing is we are taking a data-driven approach to the management of these assets. We basically are now able to understand some of the fundamental structural behavior that typically we would not be able to understand by classical mathematical modeling, but by actually looking at the assets and measuring them, then we can get far greater insights into their performance and their degradation. And of course, we can then use this data for modular construction, design, and also exploiting the use of new materials, which I'll mention. So this is a bridge that ourselves and colleagues at Cambridge in Robert May's group, the Centre for Smart Infrastructure and Construction, this was instrumented, so that this is a bridge that's now in commission. It's being operated by Network Rail, and we used fibre Bragg grating sensors. There's round about 200 on this actual structure. And just to prove it, there it is with the trains going over it. And so we can monitor this. So we can monitor the response of this structure at very high data rates. And so here's just a typical response. So this is each of the carriages hitting one of the actual sensors. And of course, we've got 200 of these. And so we can actually use this to really understand some more of the structure. I want to come on to something else that's a little bit more exciting, I would say, is the use of new materials. So materials are being used. So this is 3D printed sintered stainless steel that's actually being used to construct a pedestrian walkway, a pedestrian bridge in Amsterdam. And of course, the beauty about using this type of material is that the sort of functions, the forms and shapes that we can actually now start to employ are ones that we couldn't typically do with using standard engineering standards. The issue, of course, is that it is a brand new material and we know very little about its structural material properties. And so our team at Imperial have been doing two things. One is studying the material, but two, developing what we call a digital twin. Now this goes beyond the development of a finite element model of the structure, because we have the physical structure instrumented with the networks of sensors. We then have some computational models. In this case, it happens to be a finite element model. But what we can now do is use the actual physical structure as a means of identifying and calibrating this model in ways, again, that we would never be able to do because of the density of the data that we're able to obtain from the actual physical structure. So let me just close by saying that certainly from where I am standing, innovation in infrastructure is definitely being driven by data. There are opportunities for design, opportunity for the operation, the maintenance, and the management of infrastructure. And that is all being facilitated by data. Now, it's all very well being able to have lots of sensors and producing data, but what we do with that data is where mathematicians and statisticians come in. In addition to the sort of structures I've just mentioned, the other urban infrastructure in particular, we have people from the civil engineering department working on transportation networks, Dan Graham, power distribution, water distribution, agriculture. If you've got any questions, I'll take them later.